Hello and welcome to today's lesson. We'll be talking about expansion of difference of two squares. Let's begin. When you have two squares and you are subtracting one of the squares from the other, you call it difference of two squares. So for example, let's say we're subtracting q squared from p squared. So this is an example of difference of two squares. So what does this mean? Well, the difference of two square rule says that if you are subtracting q squared from p squared, therefore what what it actually means is that this is same as p minus q into p plus q. So the two factors of p squared minus q squared are p minus q and p plus q. We see that the two factors have opposite signs. So this is the distinguishing mark, hallmark of um, difference of two squares. So how did they arrive at this? Now let's expand this and then see how they got back to this. So p minus q into p plus q. Okay, so if you multiply p with p and then p with q and then you multiply q with p and then q with q. So let's go ahead and do that. So that's p into p plus q minus q into p plus q. Okay, this is p squared plus pq, then negative q times p, that is minus pq, then negative q times plus q gives us what? Negative q squared. Okay, so here we have positive pq, negative pq, so they cancel out. So we are left with p squared minus q squared. So we see therefore that by expanding these two, we arrive at this. So that this is the rule. So when you have two squares that you're subtracting from each other, then you arrive, we call them difference of two squares. We can apply these to numeric values. Let's say you have 9, let's say you're 9 squared minus 3 squared. Okay, so instead of solving it by finding, say 9 squared is 9 times 9, 81, then 3 squared is 3 times 3, which is 9, so 9 from 81. Instead of going that way, we can say this is a 9 minus 3 into 9 into 9 plus 3. Okay, what is 9 minus 3? That is 6. What is 9 plus 3? That is 12. So if you multiply 12 times 6, that gives us 72. Now if you do it the long way, 9 squared is 81 minus 3 squared is what? 3 squared is 9. So 9 from 81 gives you 72. So we see that this rule applies across board. So these are called difference of two squares. And so when you are expanding them, you remember that they have opposite signs. So p minus q and p plus. Let's look at a few examples. So if you're asked to expand x plus 2 into x minus 2, immediately you should be able to recognize that this is the difference of two squares. Okay, this is the difference of two squares. How do I know that this is the difference of two squares? Well, if you look at the first term in both brackets, they are the same. The second term in both brackets are the same. The only difference here is the sign that connects the two terms in the different brackets, and the two signs are opposite. So therefore, this is an example of difference of two squares. So there's a short method to arrive at the answer, and there's a long method. So first, let's do the long method. So the long method is just like what we have done so far. It's just x into x minus 2 plus 2 into x minus 2. Okay, so x times x, that gives us x squared. X times negative 2, negative 2x, plus 2 times positive 2 times x gives us 2x, plus 2 times negative 2 gives us negative 4. Okay, now we see that the middle two terms, negative 2x plus 2x, they cancel out. So what we have is x squared minus 4. So now we see that this is difference of two squares, because this can be written as x squared minus 2 squared, right? So the expanded form of x plus 2 into x minus 2 is x squared minus 4. Now the short way to do it is to remember that the middle two terms are going to cancel out, so you only work with the first term and the second term. So what do I mean? So x plus 2 into x plus 2. So in working with difference of two squares, sorry, this is my negative, right? One is positive, the other is negative. If they both of them are have the same sign, then they are perfect squares. But if they have different signs, then they are difference of two squares. Don't forget that. Okay, so what you do for the short method is to think of the first terms. So you multiply the first terms together, and then you multiply the second terms together, and then you adopt the negative sign as the value, as the sign that connects them. Okay, so the first time, if you multiply them together, that gives you what? X squared. And then the last term, plus 2 times negative 2 gives you what? Negative 4. So you write 4. 2 times 2 is 4. Then remember, you use the negative sign, so negative sign. So x squared minus 4. You can try that for any example. Let's say you have 2x minus 5 into 2x minus 5. So for the short method, you want to multiply the first terms together, and then you want to multiply the second terms together. So 2x times 2x gives you what? 4x squared. Then negative 5, sorry, this one should be plus 5. Okay, remember, the difference of two squares only when they have opposite signs. So negative 5 times positive 5 gives you negative 25. So negative 25. Okay, so we see that that's a difference of two squares. So always look out for difference of two squares. When you are pressed for time in the exam and you need to quickly find it, you can use this short method. But if you have to show all the steps of how you arrived at your answer, use the first method. So 3x minus 5 into 3x plus 5. So I'm going to start with the short method. The short method, I want to multiply the two first terms, so that's 3x multiplied by 3x, and then I want to multiply the two last terms, negative 5 times positive 5. So it's going to, because it's negative times plus, it's going to be a negative sign. So 5 times 5, that is 5 times 5. Okay, so 3 times 3 is 9, x times x is x squared, so this is 9x squared minus 5 times 5, that is 25. Okay, now let's try the long method and see whether it's going to be the same. So 3x minus 5, so we can distribute it 3x into 3x plus 5, and then negative 5 into 3x plus 5. Okay, so 3x times 3x is 9x squared. 3x times 5 gives us positive 15x. Then negative 5 times 3x gives us negative 15x. And then negative 5 times plus 5 gives us negative 25. So the middle two terms cancel out because they are opposites. They have opposite signs and the same value. So therefore, what we are left with is 9x squared minus 25. So a plus b into a minus b. Okay, so you can use the short method. So the a, multiply the first two terms, a times a, that gives us a squared, and then we multiply the two second terms, positive b multiplied by negative b is going to give us negative b squared. So that should be the answer. Okay, now let's do the long method. So a into a minus b plus b into a minus b. Okay, so a times a, that is a squared, minus ab, then plus b times, that's plus ab, then plus b times that's negative b squared. Okay, so the middle two terms cancel out. What we have is a squared minus b squared. Okay. What if you are asked to evaluate 28 times 32 without using a calculator? Is that possible? Actually, you can do any number as long as you remember the usage of perfect squares. So how can we write 28? How can we write 28? Remember, we're working with another number which is 32 that will related to 32. So we can write 28 as what? 30 minus 2. Okay? And then we can write 32 as what? 30 plus 2. So now we have turned these two numbers into what? Perfect square. Remember, perfect square is in the form of what? P minus Q into P plus Q. That's exactly what we have turned this to. So 30 minus 2 into 30 plus 2. So what do we do next? So, we're supposed to, the quick way to work with this is to what? Multiply the two first terms. So that 30 times 30. So 30 times 30 minus 2 times 2, right? Okay. So what is 30 times 30? That is 900. And then what is 2 times 2? That is 4. So you subtract 900, you subtract 4 from 900, what you have is 896. So the value of 28 times 32 is 896. So if you check it with your calculator, you find out the answer is 896. So this is a quick way by which you can find large values by using the perfect square method. So you don't want to forget, perfect squares have opposite signs. So P minus Q into P plus Q. So when you see algebraic terms like this, these are perfect squares. And the short way to arrive at the answer is to square the first term. The first term is P here, so P squared. And then square the second term, Q squared, and put a negative sign in between them. That's it. Okay. And then you can also apply this method to numbers. So if you have a number like and you can also apply that to numbers. So that's it on expansion of algebraic expression part 8. Thank you for watching.